All right, as promised, in this lesson, we are going to work on finding the x and y components of a particular vector. The last time we took the x and y component and found the resultant. Now we're going to do just the opposite of that. So we need to review just a little bit of trig again so that you remember this. If this is vector A right here, then if I go at the end of this vector and I drop a line down to the x-axis, this is going to be the y component and this is going to be the x component. Now, how am I going to relate all of these to each other? Well, if you remember from trig, the sine of theta is the opposite over the hypotenuse. So the sine of theta is going to be a sub y over a. And if you also remember, the cosine of theta is the adjacent over the hypotenuse, so that's going to be the x component over a. Now what I want to be able to do is to calculate from this what a is. So if I rearrange this just a little bit, what I'm going to have is a times the sine of theta is going to give me the y component, because remember, I know what a is. I'm trying to find the y component. And if I rearrange this, a times the cosine of theta is going to give me the x component. So these are the equations that you're going to be using in this section. Hopefully you're remembering to put all these different equations on your little index card so that you can use them on your test later on. So these are what we're going to be using to determine the x and the y component. Okay? So let's say that I have a vector 3.4 meters per second squared. What kind of vector would that be? Remember, we've talked about three kinds so far. We've talked about displacement, we've talked about velocity, we've talked about acceleration. So this one is which one? Hopefully you said acceleration with units of meters per second squared. And so magnitude 3.4 meters per second squared at 230 degrees. Now, before you go any further, stop and think, where is that? Well, if I go back to my coordinate system, if we're saying that this is 0 degrees and I'm measuring counterclockwise, this is going to be 90, this is going to be 80, this is going to be 270, and I'd be back to 360 or 0 over here. So what that tells me is that this vector is going to have to be down here in this quadrant someplace, okay? Maybe I didn't figure out exactly where it was going to be, but I know it's got to be down in that quadrant. So what does that tell me about the x component and the y component? Well, if it's in this quadrant, the x component should be what? It should be negative. What about the y component? It should be negative also. And so if I don't get a negative answer for both my x and y components, I've probably made a mistake someplace. Okay, so if I want to calculate the y component, I'm going to take a times the sine of theta, and so that's going to be 3.4 meters per second squared times the sine of 230. And so again, when you type this into your calculator, you're going to type 3.4 times 230, and then hit the sign button, and then hit equals, okay? You should come up with an answer of negative 2.6 meters per second squared, okay? So just like we predicted, that y component ended up being negative. Okay, now let's check the x component. A sub x equals a times the cosine of theta. So the x component is going to be 3.4 meters per second squared times the cosine of 230 degrees. So again, depending on which order you type that in, 230 times cosine times 3.4, or not times cosine, 230 cosine times 3.4 meters per second squared. And that should give you an answer of a negative 2.2 meters per second squared. So again, the x component came up negative, which if this vector is at 230 degrees, we predicted that that should be the case. That at 230 degrees, both your x component and your y component should be negative. So make sure that when you're doing this, that you don't just park your brain at the door and decide to accept whatever your calculator gives you. I have helped so many students who I'll look at the answer that they got and I'll say, well, can you see that that's not a logical answer? And I've gotten some blank looks before where the student will go, well, that's what the calculator said. Well, anybody can fat finger something. I mean, anybody can punch something in wrong. And so that's why you have to make sure you're thinking as you're using your calculator to make sure that the answers that it's giving you are reasonable, logical answers. Because if they're not, the mistake is probably with the operator of the calculator and not the calculator. Okay, so make sure that you're thinking through the problems at the same time that you're working through them.